Hi, today we're going to be talking about the Aurora Borealis and the physics behind it.
The concepts that we will cover include magnetic fields, energy, and collisions.
The creation of the Aurora Borealis all begins at the sun, where at its core, hydrogen atoms collide together under intense pressure to form helium atoms in a process known as nuclear fusion.
This collision releases a great deal of energy, indicating that this was an inelastic collision. This energy, which is in the form of light, radiates outwards from the core of the sun. As it radiates outwards from the core of the sun, it encounters convection cells.
Convection cells are places inside the sun where dense matter sinks while the less dense matter rises. This causes electric currents of charged gas, which causes magnetic fields to form.
This electrically charged gas pushes the magnetic field outward until it snaps like a rubber band, and this electrically charged gas, also known as plasma, travels through space in what's known as a solar wind. As the solar wind travels through space at about 800 kilometers per second, it encounters another essential component in the creation of the Aurora Borealis, the Earth's magnetic field.
While the inner core of the Earth is made out of solid iron due to intense gravitational pressure it experiences, despite it having a temperature near the surface of the sun, the outer core of the Earth is composed of liquid iron.
There, due to differences of temperature, pressure, and composition of the Earth's outer core, convection cells form. The flow of liquid iron generates an electric current, which in turn produces a magnetic field that forms the Earth's magnetosphere.
The magnetosphere protects Earth from charged particles from the sun, like solar winds.
Solar winds are essentially made up of plasma, which is basically ionized gas, meaning there are a lot of ions, also known as charged particles, and electrons floating around in it.
Most of the solar winds are blocked by the Earth's magnetosphere, but some break through where the magnetosphere is the weakest, at the poles.
At the poles, the electrons from the plasma encounter nitrogen and oxygen from the atmosphere, and when these electrons collide with these gaseous atoms, they transfer energy to them and excite them.
To go back to the ground state, or their original energy level, the now excited atoms have to release energy, and they do so in the form of protons. A proton is a unit used to measure electromagnetic radiation.
The light emitted by photons is what we see when we witness the Aurora Borealis, and the colors of the photons differ with where the electrons collide with the oxygen or nitrogen.
A collision with oxygen up to 150 miles produces a yellow-green light. Anything higher emits a red light, and a collision with nitrogen up to 60 miles emits a pretty blue light.
All of these colors can mix together and form the beautiful shades of pink, purple, and white we also see in the Aurora Borealis.
The Aurora Borealis is always occurring because we are always being bombarded by solar storms, but you can only see the phenomenon at night because at daytime the sun outshines the Aurora Borealis, so you can't see it.
And that's the physics behind the Aurora Borealis. Thanks for watching!